All right, so here I got the notes for the second set for radicals. So we're solving radical equations 2. In this case, we'll have x's on both sides of the equations, so it's going to be a little bit different. When we square both sides of the equation and x is on the right, not underneath the root, we may end up with what's referred to as an extraneous solution. So that's a solution that comes out of the algebra, but happens because we squared both sides, which introduces an extra solution. So we do need to check our answers at the end to make sure our solutions are, in fact, valid. Okay, so the root is already by itself, so same steps as the previous section. So I can go straight to squaring. So over here, the root cancels. Now on the left, when I square, I have something that looks like this, a quantity squared. That is not x squared plus 9. That means x plus 3 times x plus 3. It is a FOIL problem. X squared plus 6x. Well, we'll do fully. And then combine like terms. Now, there is kind of a shortcut to get the FOIL if you have a quantity squared. So the trick is to get the first number, you just square the front. So x squared is just x squared. To get the back number, you square the number. 3 squared is 9. And to get the number in the middle, you multiply them together, x times 3, and then you double. The reason that you double it is that if you think about the FOIL, I do x times 3 twice, once on the outsides, once on the insides. So I get 2 of them, so I can just double the value. Now, because I have a quadratic, everything has to move to one side of the equal sign. So this x and this 23 need to move across. So 0 equals x squared minus 5x minus 9 minus 23 is, I don't know, grab a calculator, negative 14. So because I have a quadratic, I can either factor or do the quadratic formula. I'm going to factor in this case. So I need 2 numbers that multiply to make negative 14 and add to make negative 5. That's negative 7 and positive 2. So the 2 solutions are 7 and negative 2. Oops, lost the negative. Negative 2. So to check, I need to plug. I think I've done something wrong. No, I feel like something's off here. Let me think about this. Okay, figured it out. Mistake's right there. 6x minus x is positive 5x, which means I have my signs backwards. That should be x plus 7 and x minus 2. So the solution should be negative 7 and positive 2. So if we plug it back into check, if we plug those numbers in, we do need to make sure we get the same thing on both the left and right hand side. So when we check, we have to plug our values back into the original. So, and make sure we get true statements. So if I plug negative 7 in, that would be negative 7 plus 23 underneath the root. On the right, negative 7 plus 3. So that's negative 4. That's the square root of 16. Square root of 16 is positive 4. Positive 4 does not equal negative 4, so negative 7 can't be a solution. If I do 2, that's the square root of 2 plus 23 equals 2 plus 3. So that's root 25 equals 5. 5 equals 5 is a true statement, so 2 works. Now there's kind of a quick way to check, and mostly if the solution's not going to work, it's because the left-hand side is positive and the right-hand side is negative. So usually what we can look for quickly, if we want a quick check, is that our x values we have cannot cause a negative number on the right-hand side, the side that's not underneath the root. So that's the other way to check. All right, so for number 2, root's by itself, so we can square both sides. So I'm going to do the shortcut here on the right. So to get the front, we square the x. To get the back, we square the 8. To get the number in the middle, we multiply them, so that'd be 8x, and then we double. So 16. Because we have x squared, everything has to move to one side. So that's going to be 0 equals x squared. That's going to be 9. And that's going to be 64 minus 46 is 18. So to factor, I need 2 numbers that multiply to 18 and add to 9. That is 6 and 3. So my 2 possible solutions would be negative 6 or negative 3. So negative 6 plus 8 is a positive number, so that's okay. X is negative 3. Negative 3 plus 8 is also... Oh, no, I made a mistake there when I said it's a positive number. It can actually be 0 as well. So it just has to be not negative, which is not quite the same thing as positive. Not negative includes 0. Positive means 0 is not allowed. All right, so for 3, go ahead and square both sides to get rid of the root. So 41 minus 5x. Over here, we'll do our shortcut. So square the x, square the negative 7. Note that this number in back is always positive because when you're squaring a number, it doesn't matter what that sign is, it comes up to be positive. Multiply them together would give me negative 7x. Double would give me negative 14x. So move everyone over. So 0 equals x squared minus 9x plus 8. So two numbers that multiply to positive 8 and add to negative 9 is negative 1 and negative 8. So my two possible choices are 1 and 8. So 1 minus 7 is a negative number, so not allowed. 8 minus 7 is a positive number, it's okay. Or is a non-negative number. Square on both sides to get rid of the root. So 6 minus x, so shortcut, square the x, square the negative 6. X times negative 6 is negative 6x, doubled, negative 12x. Bring the 6 over, bring the x over because we have a quadratic and we need everybody on one side. So two numbers that multiply to positive 30 and add to negative 11 are negative 6 and negative 5. So my possible solutions are 6 and 5. So I plug 6 in. 6 minus 6 is 0. That's not a negative number, so 6 is okay. 5 minus 6 is negative 1, not allowed. Okay, so for our last one, square both sides, get rid of the root. 6x plus 7. Shortcut would give me x squared 4, so 2 times x is 2x. Double would be 4x in the middle. Then bring everybody to one side because we have a quadratic. X squared minus 2x minus 3. So two numbers that multiply to negative 3 and add to negative 2 would be negative 3 and positive 1. So my solutions are 3, potential solutions, 3 and negative 1. 3 plus 2 is 5, that's not a negative number. Negative 1 plus 2 is 1, that's also not a negative number. So in this case, both solutions were valid. And that brings us to the end of the section.